Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with spectroscopy for chemistry, particularly ultraviolet visible spectra. This is lecture number 40 and in this lecture I will explain you numericals of Diene system. Now this is example which I have given you. Here you can see there are double bonds and there are also double bonds, but there is no common cross conjugation double bond in any case. So there is no cross conjugation. Remember that there is no cross conjugation in this case also. But there may be more than one systems. Let us see this one. So first of all, we'll consider this one. We start from here. 1, 2. So this is your system. 2 double bonds. Okay. So both double bonds are outside the ring, and that is called open chain Diene system. So it can be system A, and for system A, let us calculate. So first of all, we'll see open chain Diene system, and for that we will take 217 nanometer. Okay, extension is there or not? Yes, there are extension over here, and we can see there are 2 alternate double bonds in extension. So there are 2 extra conjugated double bonds. And for that we will add 60 nanometer because there are 2 extra conjugated double bonds. So for one we'll add 30. Next is exocyclic double bond. Well, all double bonds are outside the ring and they are not connected. Yes, this double bond is connected to the ring. Okay, because it is a part of this 7-member ring. This double bond is outside, but second double bond is endocyclic because it is in this ring. But both carbons are in the ring, so this is not exocyclic. Next is third one double bond, which is in green, and here this carbon is a part of this double bond, second carbon is outside the ring. So this will be exocyclic double bond for this one. So there is only one exocyclic double bond. So 5 nanometer for exocyclic double bond. And no question for this because there is no ring over here. Okay. Next is ring residue or substitution. Start from here. So no extension outside the ring, outside the system. Then we go here. Yes, this is ring residue for this carbon. Next is this ring residue for this carbon. This is also ring residue for this carbon. Next we'll go here, this ring residue for this carbon, and there are 2 ring residues for the end carbon. Okay, so total number of ring residue 1, 2, 3, 4, 5 and 6. So 6 ring residues. So 30 nanometer it will be added for ring residues. Nothing is left, therefore now we have to calculate lambda maxima for this one. Okay, so total will be lambda maxima for system A. Now we will see system B. This is system B. Okay, and where is the system? We start from double bonds. Okay, so, and both double bonds are in this ring. So we start from here, here and here. This is your basic system, and here both double bonds are in the ring, and therefore we consider this as homoannular Diene system. And for homoannular Diene system we are adding 253 nanometer. Okay, now extension of double bonds. Extension, we go ahead with single bond, double bond. Should we consider this as extension? No. Why? Because there are 2 single bonds between these 2 double bonds. One is of the system and this is out of the system, and therefore this double bond is nowhere It is not in the system. Okay, so please do not add anywhere in this one. Now we'll see extension of this double bond. There is only one extra double bond, and therefore extra conjugated double bond is 1. And therefore we will add 30 nanometer for this one, this double bond. Okay, next is exocyclic double bond. For exocyclic, this one, well, this carbon is a part of the ring, this is also in the ring, and therefore it is not an exocyclic for ring A. But if it is ring A, this is ring B, then for ring B, this carbon is in the ring B, but the first carbon of this system is not in the ring B, so it is exocyclic for ring B. Next one, it is also exocyclic for ring B. Why? Because this carbon is in the ring, but this carbon is outside the ring, so it is not exocyclic. This is exocyclic. Well, the third extended double bond is not an exocyclic. So 2 exocyclic double bonds, and therefore we will add 10 nanometer for this one. Next is ring residue. Substitution is nothing but only ring residue. So we start from here, one ring residue, that is this carbon. Next we go here, both are in the system, so next will be this one. This is ring residue for this carbon, then this is ring residue for this carbon. Okay, we go down, this carbon has one ring residue over here, and this carbon has 2 ring residues. So total 1, 2, 3, 4, 5 and 6. So 6 ring residues for this one. So total 30 nanometer is added for that one. So now we'll have to add total and find out lambda maxima for this system. Okay, so this way there are 2 different systems having 2 different lambda maxima. Okay, but they are not cross conjugation, remember that. Next, this is an example. Let us take this example. Now here, is there any cross conjugation or not? That we'll have to find out. Yes. Why? Because this double bond is common for left side ring, left side system as well as right side system. So first of all, we'll consider right side system, and this is the right side system. And here we have 2 double bonds, but both are outside the ring. So for this system A, we call it A system. A system. It is open chain Diene system, and for that we will add 217 nanometer. Next, extension of double bonds. Can we extend this system? Yes. Why? Because there is one double bond over here. So number of extra conjugated double bonds, 1, and therefore we will add 30 nanometer for this one. Okay. Next, exocyclic double bond. Yes. Here you can see this is a ring A, and one carbon is in this ring A, but this carbon is not outside in the ring, so it is called exocyclic double bond. So 5 nanometer for exocyclic double bond. Next is ring residue or substitution. So we start from here. This will be ring residue for this carbon. Next is going here, ring residue. Again, we go here, this and this one. So total 4 ring residues, and therefore we will add 20 nanometer for this one. So now we have to make a total of this and find out lambda maxima. Okay, this is definitely cross conjugation. Okay, this is an example of cross conjugation. Why? Because the system remain common for both. Now next one is for system B. This is system B for this one, and we can extend this to this side. So sorry, this will be double a system. Here you can see this is also a system. Extension is possible. Yes, we can extend this up to this double bond. Okay, so original system is again open chain for B system. Open chain Diene system, and for that we will add 217 nanometer. Then we will take extra conjugated double bond. Yes, there is only one extra conjugated double bond. For that we will add 30 nanometer. Okay, then exocyclic double bond. Well, there is no ring, so no exocyclic double bond, 0 nanometer for this one. Now substitution, and first of all we'll consider ring residues. How many ring residues are present along with this? Let us see this one. So for this system, this will be ring residue 1, then 2, only 2, because this is substitution. So 2 ring residues for this one, so we'll add 10 nanometer for this one. And now for OCH3 group, the value we take for OR is about 6 nanometer, I think. So for OCH3 we will take 6 nanometer, and then make a total of this. Okay, so this will be lambda maxima for this system B. So here it is example of cross conjugation, and we have two different systems A and B, and find out for both. Thank you so much.